So today we're going to be talking about portfolio backtesting in Python. So let's say you're thinking about how you want to construct your portfolio. What percentage do you want to allocate to what? Do you want to allocate 10% to stocks, 50% to stocks, 5% to Bitcoin? What do you want to do? Now, to figure that out and to do the maths in our head, we can look back in time at how a portfolio of that weighting has performed historically. Now, obviously, the past is not a reliable predictor of future returns, but it can give us an idea of the upside, the downside, what risks we're taking on here, and whether that's something that you might want to do. So what I've done here is I've drawn up two portfolios. One is the S&P 500. So that's returned sort of I think it's something like 70%. So you can see it's like 1.93, so like almost a doubling really since 2016. So a decent rate. But if you just allocated 5% to Bitcoin and kept 95% in your S&P 500 fund, you can see that you would have gotten more like a 9-fold return while only risking 5% of your portfolio. And so when you run charts like these, you begin to see the upsides, the downsides, and risks and that kind of thing. So let's dig into this and create something like this for ourselves in Python, where we can configure it. We can put our own portfolios in there with different cryptocurrencies. You don't have to use stocks. So let's go. Alrighty then. So the first thing we need to do, obviously, is to create some file. So I'm going to call mine tutorial.py. And then let's go ahead and import the libraries that we're going to be using. So we're going to be using yfinance because we love yfinance on this channel. As yf, just for a shortcut, and import pandas as pd. And then we're going to want matplotlib to actually draw the graphs. So that's going to be import. There we go. Right. So we've got our three things. Now we need to think about how we're going to enter our data. So what I'm going to do is I'm just going to feed it in as like a dictionary to our program. So I'm going to create a variable. I'm going to call mine weightings. And I'm going to make it into a dictionary. So it goes in curly braces like this. And what we're going to want to put here is the ticker symbols as per the Yahoo Finance website. So you can go up here and you can look up ticker signals for any particular stock or cryptocurrency. So in this case, it's BTC USD. So that's what I'm going to put in here. And so we'll say BTC USD, and then we'll assign the weighting to that. So I'm going to assign that weighting as 50%. And then we can put another entry in there and say XMR USD. So that would be Monero USD. And we'll assign a weighting of 50% to that. So we want to see how this portfolio would do over a given period of time. Okay, so we've decided on what our portfolio looks like. We can always change that later. Now let's pull in the data. Now the way I'm going to do it is we're going to have a base data, which is going to be the first element. And then we're going to glue all the other price data on to that table using left joins or like a merge join. Now, don't worry, we'll see what that actually looks like in a minute. So the other thing I'm going to do is I'm going to create a list with all the data that we need to fetch. This just makes our life easier later on. You could, of course, do this manually, but I'm doing it this way because we're going to loop through this list later on, and so we can easily extend the list. You'll see why. So BTC USD and XMR USD are our particular assets that we're grabbing there. Okay, so now we'll do base data. So this is going to be our main data frame that we're going to glue on all the other price data to later on. And so usual routine here with yfinance, you do yf.ticker, and then we're going to put the first item of our members list in there. And then we'll do .history to get historical data. And then select period equals max in as a string there. And then we can do .reset index. This is just like standard stuff. If you've seen any of my other videos, it's all sort of this format for yfinance. Then you do like a date and open. So the reset index there is because it will use the date as the index on the side as opposed to just a number. And we want the date to be a column. And so that's why we have to do reset index. And then this bit at the end here is just saying that we want the date and the open columns. So the date and the opening price on that date. You have to pass that as a list in order for pandas to understand. All right. So we've got that. Now we want to make sure date is in date time format. I like to do this to make sure nothing's going to go horribly wrong. You might be able to get away with not doing it, but I'm going to do it. So base data date is equal to pd dot to underscore date time. And then you just want to give it the same column. So base data date. So we just select the date column from base data and we convert that to date time. And then the final thing we're going to want to do is to change the name of open. So we don't want it to be just called open. We want it to be called BTC USD or whatever it is. And so for that, we're going to have to do like a column mapping. And so that's pretty easy to do. You just do like a base data equals base data dot rename. And then you just provide it a dictionary here. So columns equals, then we create a dictionary. And we'll say open, and we want to map that to the first element of our members list, because that is the ticker that we actually got over here. I just noticed that I misspelled that there. Okay, so let's print this out and see if it's actually working or if we've got any errors or anything. So base data, right, and then let's go down to all of the screen. Python 3 tutorial.py. Perfect, actually seems to have worked. Let's do a brief sanity check on the data there. So we're getting data from 2014 and the price of Bitcoin was about 465. Seems reasonable to me. We can always check it on the chart. So in 2014, yeah, we're just coming off the high in 2013. So that seems reasonable to me. Looks like we've got all our data coming in. Nice, and we've got the most recent data here as well. So perfect. Obviously, we need more than one if we're going to construct a reasonable portfolio that you might use. So now let's think about how we're going to get all our other data for all our other columns. So what I'm going to do is say, so firstly, let's do a check, because if you've only got one item in the portfolio, we don't need to bother with all of this. So if length of members is greater than 1, you're going to want to have more than 1 anyway, but this is just a sort of sanity check. Then what we're going to do is we're going to do a for loop. So we're going to do for x in range, and then go from 1 to the length of our members list. All right, so what we're going to do? Well, we're going to do basically the same thing we did up here. So we're going to grab the data from yfinance, we're going to format it nicely, we're going to take the date, convert it to date time, and we're going to map the column name, so open, we're going to map that to the actual ticker symbol. So we're going to do the same thing. So why not just copy and paste these in here, and we'll shift them up a bit. Obviously, we'll have to change the variable names here. So let's just call it new data. New data. New data. And new data. Let's see if, yes. So we're going to have to change 0 here to an X, because that is our index that we're sort of looping through. Okay. And then the final step here is we just change the value of base data. So we're going to glue on new data to the side of base data. You'll see what I mean in a minute. So we'll say base data is equal to pd.merge base data and then new data and then on equals date. So that's the column that's going to merge them on. All right, so let's see if this is working, because we don't want to be plowing on ahead if it doesn't actually work. Ah yeah, found the error there. This needs to be changed to new data. Thought I was going a little bit crazy there. Let's try that again. Ah, there we go. As you can see, we've now got Monero data and Bitcoin data. And the prices look reasonable to me here at those times. Chad here from the future. Make sure you do actually rename all the instances of base data here to new data. I missed one out in the tutorial. It still works just fine. Just it on your own version of things. Just change this one here to new data. As always, the code will be on the GitHub repo if you want to check against that. I just thought I'd make you aware of this, as it can throw your numbers off a little bit in the data frame and make your portfolio weightings a bit dodgy. So there you go, just a mistake. So why did we go through all this effort with the for loop? That's because we can now easily grab any information that we want about any other stocks and stick it on the edge of this data frame. All you have to do is add an element to this list. So you can do Tesla, for example, or we could do Coca-Cola, and let's just watch it work. And there you go. You've got all that data as well, which is really nice. And so you can see how easily this is to extend and expand and create your own portfolio data in there. So let's get rid of these for now, because we're not going to actually use them. Now, we've actually done most of the work now that we've got our information in one data frame. What remains to be done is to normalize the data. So we're wanting a return on investment. We don't necessarily want the absolute values of Bitcoin or Monero at any time. What we're interested in is what percentage return we're going to get over a period of time. And so to do that, you have to divide the numbers here, so the prices, by the starting number. And so we'll see the eventual return on investment. So to do that, that is relatively easy. So you just do, you can do something like this. So you can do 4x in members. Then you can do base data is x is equal to base data x divided by, then you get the first element, so base data x dot eloc 0. So what you do is, so we set this column, so BTC USD, for example, say takes the first element of members, is equal to this column divided by the column at index 0. So divided by this number, which is exactly what we want. And so hopefully this will work. There we go. You see these have all been normalized to a value of 1 here, which is exactly what we're after. And so you'll see that over the last sort of 7 years, if you'd invested in Bitcoin at this specific date, you would have got a 124 times return on your money. So not bad. Now, obviously, you might not want to look at an investment made on this date. You might want to look at an investment made on a different date. Now, that is pretty easy to change. So all we have to do here is we have to cut off information before a certain time. And so you just do like base data is equal to base data, and then we just select for a specific date. So you got like a base data date, and then we want to say the date is greater than, let's use like 2017. Let's say January 1st of 2017 is when you've made your theoretical investment. So 0101. And then we should see that all the data now comes from that point, and the return on investment is obviously different because you invested at a different time. All right, so now all that remains is to combine this data into our actual portfolio weightings and to similarly glue that on the end there or plot it in some kind. And so what we need to do is we need to create some kind of function that's going to take in our base data and our weightings, and from that calculate a new column, which is our portfolio return on investment at any given time, and then glue that on the end. So let's go ahead and do that. Let's create a function that does that. So let's just go up here, just below our config area, and we'll do define portfolio calc, let's call it. And it's going to take a few different variables. It's going to take weightings. So it wants our portfolio weightings. It's going to take in the base data frame. And it's also going to take the name of the column that what we want it to be called. So I'm just going to shorten that to data actually. Okay, so all we have to do here is say data name. So we're going to create this column. And this is a slightly dodgy way of doing things, but I found it to work. So we're going to do sum of a list here. So the list is going to be done with list comprehensions. And so let's do int times, so int of weightings x. So we get the first weighting, and then we will multiply that by data of x, and then divide that by 100 to get a percentage. And then what is our x variable here? That's going to be for x in list weightings.keys. Perfect. So what is this actually doing? It's grabbing the keys here. So that will just be the first elements here. So it'd be BTC USD and XMR USD. It's going to grab the weightings and then grab the keys, convert that to a list so that we can iterate over it. And then, so each of these is going to be an X, so we can think about, so the first thing it's going to do is it's going to take weightings for BTC USD. So it's going to take 50. It's going to convert that to an integer. It's then going to multiply that by taking data of X. So data is just our base data. That's what we're going to feed in there. So it will take all the BTC USD prices, multiply them by the weighting, and it'll do the same with Monero, and then add them together at the end. So it will create a nice weighted portfolio. And then all we want to do here is just return data. So this should now work. Let's go ahead and test it down here. So we'll do base data equals portfolio calc. And then let's feed in our weightings. Let's feed in base data. And then let's call it our portfolio. Perfect. Right, so let's see if this is working. It's not working because weightings isn't defined. Let's go ahead and check that. Yes, it's weighting, not weightings. Right, so that seems to be working. We can get a rough idea of whether it's working by noting that 37 is pretty much halfway between 16 and 58, and we had a 50-50 weighting in our portfolio, so everything appears to be working. Also, I've just realized that really we shouldn't be putting spaces in Panda's data frame name, so let's just change that to a dash. All right. So now we want to plot our portfolio. This is going to be fairly easy. You just do plt.plot base data date on our x-axis, and then you want the portfolio value here. So we'll do our portfolio, and then you want to give it some kind of label. So if we're plotting multiple portfolios, we want to make sure they show up on the legend differently. So we'll do label equals our portfolio. All right, and then you do, I guess we'll do plt.style.use, make sure it looks nice. And we'll go crazy this time. We'll use seaborn instead of the usual plt.dark. All right, and then plt.legend. And then we'll set the location of that to be upper left. Perfect. So the legend is just going to be a little box on the sides that tells us which element's which in the graph. Okay, and finally we should be able to do a plt.show, and this should be us rocking and rolling. Nope. Evidently spelled something wrong there. Yep, no hyphen there. Perfect. So we've got our portfolio here, which is a 50-50 weighting of Monero and Bitcoin. Right, so this is reasonably cool, right? But we want to do something a bit nicer. And so now we'll get to see just how extensible our program is here. So let's do something like we did before, where we did a combination of stocks and cryptos and messed about with the weightings. So let's think of an example. So let's do a S&P 500 portfolio with different weightings of cryptocurrencies and see how that affects your outcome over different periods of time. So let's do BTC USD, and let's start with a 1% allocation. And then on our other one here, we'll go grab a S&P 500 fund. So S&P 500. I guess we can just use SPY. Let's use that one. And that's going to be 99%. Make sure they add up to 100 there. And then I guess we'll just copy this 2 times. And we'll say a 3% allocation and a 5% allocation. Let's see what this would do to your theoretical portfolio. Although we could do something different. We could have like a 3%, 95%, and then we could do Ethereum USD and have that at 2%. Okay, so weighting, we'll say 1, 2, 3. And then all you have to do, scroll down to the bottom and plot them, and it should just work. So we'll just copy that twice there, weighting 1, 2, 3. So there you go. Here we've got 3 different portfolios of more and more aggressive picks, basically. So this one has 5% crypto with lots of Ethereum. This one's 3% Bitcoin, 97% SPY, and this one's 100% SPY. And so you can do this with any assets that you hold. You use gold or bonds or anything really that can be gotten from the yfinance API. You could also just load in CSVs as well if you wanted to, and the same approach of merging them all into one table and then calculating the weightings would work perfectly fine for this kind of thing. And so yeah, that's a nice tool I thought you might find useful in your analysis.